This presentation shows how the composition of the precipitation bath, specifically the concentrations of sulfuric acid, H₂SO₄, zinc sulfate, ZnSO₄, and sodium sulfate, Na₂SO₄, affects the swelling and properties of viscose textile yarn during spinning and finishing. Viscose textile yarns produced by centrifugal spinning show property non-uniformity, and how precipitation bath composition can be optimized to reduce swelling and improve cake weight. Viscose yarn cakes suffer from non-uniformity because inner layers prevent outer ones from shrinking fully. This creates a rigid housing effect, resulting in uneven relaxation and fiber properties. Right concentrations of sulfuric acid, zinc sulfate, and sodium sulfate in the spinning bath is very important to minimize swelling, enhance fiber properties, and increase cake weight. By balancing acid and salt concentrations, swelling was reduced, uniformity improved, and cake weight increased.
Sodium sulfate reduces hydrogen ion concentration and strengthens fiber uniformity, while zinc sulfate promotes fibrillar structure through transverse bonding.
The optimum bath composition was found at 120 grams per liter sulfuric acid, 300 grams per liter sodium sulfate, and 12 grams per liter zinc sulfate, yielding minimum swelling and uniform yarn properties.
Detailed effects of bath components on yarn swelling. 1. Sulfuric acid, H₂SO₄. Effect: the influence of sulfuric acid concentration on primary swelling is complex and nonlinear. Across all tested zinc sulfate concentrations, the minimum swelling is consistently observed at 120 g/liter H₂SO₄. Explanation: at this concentration, the cake volume is minimized, leading to a more uniform distribution of yarn properties. Too little or too much sulfuric acid increases swelling, so 120 g/liter is optimal for minimizing swelling. Increasing H₂SO₄ above or below 120 g/liter led to higher swelling percentages in both freshly spun and finished yarns. 2. Zinc sulfate, ZnSO₄. Effect: increasing ZnSO₄ concentration in the bath generally decreases the primary swelling of the yarn. Explanation: zinc ions promote the formation of a finely fibrillar yarn structure by creating transverse zinc xanthate bonds. This structure is less prone to swelling. Example: at 4 g/liter ZnSO₄, the minimum swelling was 140%. At 16 g/liter, swelling dropped to 122%. The optimal value for minimum swelling was found at 12 g/liter ZnSO₄, swelling equals 120%. 3. Sodium sulfate, Na₂SO₄. Effect: increasing Na₂SO₄ concentration in the bath also decreases primary swelling. Explanation: higher Na₂SO₄ reduces the hydrogen ion concentration, which leads to a more uniform fiber structure and increases the dehydrating power of the bath. This results in less swelling. Example: raising Na₂SO₄ from 200 to 300 g/liter reduced swelling from 180% to 122%. 4. Combined effects and optimum composition. The lowest primary swelling, 120%, was achieved with a bath containing 120 g/liter H₂SO₄, 300 g/liter Na₂SO₄, and 12 g/liter ZnSO₄. Secondary swelling, after finishing and drying, is less sensitive to bath composition, as further structural changes occur during these later stages. Optimum bath conditions that minimize swelling, improve uniformity, and increase cake weight.